Hi, it's Jan Beta and I'm in the lab here with this 1990s Sony integrated stereo amplifier that needs some TLC. This is a Sony TA-F550ES, which is a mid-range Sony amplifier from the very early 1990s. According to the internet, these were built in 1990 and 1991. And it is a pretty solid amplifier. The Sony Hi-Fi stuff from that era is generally really well built and down-to-earth audio equipment. So this is not any kind of audiophile machine, but it is a very decent mid-range 1990s stereo amplifier. And this particular one has some issues. It reportedly has some issues with the switching and some flaky potentiometers, but nothing a bit of elbow grease and contact cleaner can't fix, probably. There's a lot of switches on here, so there's a lot that can go wrong in the signal path. That's one of the major issues with this. It does work, but after a while it gets really hot and it turns off, or basically goes into the protection mode. I think the bias setting might be misaligned or something like that. We're going to look into that. Maybe it's going to be a quick fix. Maybe we're going to have to dig a bit deeper. There may be wonky transistors in here or something like that. Let's open this up and have a look. This should be really fun to work on because it's from the era when they didn't use digital stuff in these, and it was at the end of an era, basically. I think in the 2000s they started to build in like HDMI stuff and things like that. This opens up with screws around the parameter, 2 in the back, 2 on each side, none on the front. The front panel is going to stay on, I think. Maybe we're going to have to take that off later, but I'm going to open the whole chassis here at first. This is a really heavy machine, and I think it's quite powerful as well. I think I read something like 120 watts at 4 ohms. So it is quite powerful, and it's quite heavy, as these things used to be back in the day when they used proper amplification. This is a Class AB amplifier as usual, I think. None of that Class A audiophile stuff, just a powerful, good amplifier. And I really like these Sonys because Sony was always a good brand for hi-fi equipment. Not the high-end brand, but the solid, usable, reliable brand. Just the kind of stuff I like. I think Sony still makes good stuff, but they're probably not making things like this anymore. This thing looks beefy and down to earth indeed. We have a huge toroidal transformer here. Huge 12,000 microfarad capacitors here for filtering the power from the transformer. Large diodes to rectify that. Some electrolytic capacitors of the smaller varieties, some driver transistors. I think this is one of those. That's an STK. That's the driver probably for the power transistors, which are under this heatsink. I can see the legs poking through here. They're on the back side of the board. Large heatsink, of course, because these run rather warm in normal use. We have 2 little potentiometers to set the bias of the transistors, and I think that's the first thing I'm going to take a look at. These are probably biased incorrectly, so they run hot. If they are good at all, but since this is working and sounding decent, I don't think there's too much wrong with it, really. I downloaded the service manual, which thankfully was readily available online. I'm going to put a link to that in the video description. And here's our idling current adjustment. That's what I'm talking about. We're going to have to measure the idling current over 2 resistors for both channels. This, of course, is only stereo, so only left and right channel. We want to adjust that for 7 millivolts using our little potentiometers on the board that I've shown you. These are our test points, I think. Let's see. They're even labeled with 7 millivolts on there. Ah, Sony, you gotta love Sony. They made serviceable stuff. I don't know about their stuff these days. Also one of the few brands that always put little arrows to where the screws are that open up the case. I don't know if they do that still, but they did. That's nice. I like stuff that's repairable. On purpose. And also they made good service manuals, which is also quite good. This is like felt, the red stuff, to minimize vibrations. Never seen that in an amplifier, really. That's nice. Nice touch. I already really love this thing. I mean, it is a really simple circuit. A lot of the stuff is integrated in the SDK, I think, that's over here. These are integrated circuits, kind of called hybrids. There's a full preamplifier section in this chip, basically, and that is used as the preamp driver for the power transistors. These are getting difficult to find these days, so if you need to replace one of these, it might be difficult to get spare parts for those, but it seems to work fine. Maybe that's at fault, I don't know. We're going to see. Oh, this is the switch for the phono cartridge. That is really proper design here by Sony. The switch for switching between moving magnet and moving coil phono cartridges, which of course these higher end amplifiers have. The switch is actually located close to the phono input here, and the button obviously is located on the front panel. So you switch the button on the front panel, but the switch is in the back here close to the inputs, so the signal doesn't have to travel a long way, because that is a very low energy signal and very prone to interference. You don't want that to have a long way to travel, basically. Let's set the idling current here. So I connected my test leads to the test point there, and we're going to adjust our little potentiometer to 7 millivolts, and the test point is actually quite nicely accessible. The test leads are of course connected to my multimeter here, which I'm going to set to millivolts because we only need 7 millivolts. That's a really small measurement. I'm going to turn this all the way down, the volume potentiometer, and then we're going to have to let this run for 10 to 15 minutes to warm up, and then we can take our measurement. I'm going to keep an eye on the voltage anyway during the startup phase, so we can instantly see if something is completely off, which I think might be the case here. Yeah, I'm going to plug this in and let it warm up while monitoring the voltages. Turning it on, and this should go out of protection in a second. This is now showing red. Now it's green. And you can see the value climbing there. I'm going to set a clock for like 10 minutes and have a look after that. That's nothing to worry too much about at this point. So we are 10 minutes in, and I actually adjusted this a bit. This was a bit on the high side, and now it just stabilized around 7.3. We want to have this at 7, so this is not too bad, really. Just going to slightly adjust this to be as close to 7 as we possibly can do. Okay, that's as good as it gets, I guess. I'm going to turn this off and do the other side. This channel is adjusted very nicely. Another thing I realized is that the SDK gets really hot. So maybe there's something wrong there. Let's adjust the other channel first. And we're doing the exact same thing, except for this time connecting to the other little test point there and using the other potentiometer. Okay, same procedure. I'm going to keep this running for 10 minutes and then I'm going to measure my voltage. Yeah, while we wait, I'm just going to look up how hot these SDKs are supposed to run. I'm not sure about that. Maybe they are supposed to run hot like that. Okay, the operating temperature on these is 115 degrees Celsius. It runs really hot. That's why there's a nice copper heatsink attached to that. Yeah, but our voltage is a bit on the high side, as you can see. I'm just going to turn it down slightly. Yeah, this is rising for quite a while and then it stabilizes. And we want to set that stabilized voltage to 7 millivolts. So I'm going to be back in 10 minutes my time, 1 second your time. And it's stabilized at 8.3 or thereabouts. So we're going to give it a bit of a touch to go a bit lower, closer to 7 millivolts. Okay, that looks really good to me. And the SDK, still pretty toasty. But given that it's meant to be operating at temperatures up to 115 degrees Celsius, that's actually normal. I don't know what temperatures this is, but it's not 115 degrees Celsius, or else I would have burned my hand. So yeah, we are satisfied with our idling current. That should now be all in spec very nicely. And our SDK is running at around 40 degrees Celsius. That's completely okay. So to determine what is at fault, I have connected these nice old Heco speakers that I had in the lab. And I also connected a pair of headphones. And what you can do to find the fault, in case you have determined that this is mostly working and doesn't harm anything that you connect to it, you can connect an audio source. In my case, I connected my old phone here, and then have a listen on both the headphones and the speakers. And I connected the speakers to channel B because that seems to be a bit better. And then we can have a listen to our audio source, which you can also connect to different inputs here to determine if the input switch is faulty. Just listen, and if channels cut out or something like that, you probably have a problem with the potentiometers or with the speaker relays. And for the speaker relays, there's a very simple test. You just have to listen to what comes out of the speakers and tap them. And there's one for channel B, which I think is the first one here. You want to use something non-conductive because the mains power inlet is just around here. And if you tap them and something changes in the sound output, so you have channels that cut out or something like that, you probably have bad relays there. And I don't know if you heard that. I had some music playing here, and indeed, when I tapped the relays, the sound was kind of intermittent. So we definitely have some relays that are not working reliably. You want to compare the output from the headphones with the speakers. Usually in these mid-range amplifiers, the output that goes to the headphone jack is just the signal that goes to the speaker relays as well, but before the speaker relays. So you have the output from the power amp going to the headphone jack just through some resistors to bring down the signal level to headphone level, but it is basically the same signal, so you can easily troubleshoot both signals before the relays and after the relays with the speakers after the relays and the headphones before the relays. Otherwise, it is the same signal basically. So you can use the headphones to determine whether your potentiometers or your switches need some more cleaning, which they do. There was some crackle and things like that on those, so we're going to have to clean the switches, but we're definitely going to have to take a look at the relays because those are super flaky. So that's the main fault in this unit here. These are basically just an electromagnetic switch that closes some contacts to go to the speaker terminals. This one has two separate relays for the speaker outputs A and B. Sometimes you only have one of these, but both of these have issues. I had the speakers connected to both A and B, and both of these are a bit flaky when you hit them, or if this is running for a while, these channels cut out and things like that. So these are definitely faulty. And you can open these in circuit, but I found some replacements that we're going to look at in a second once I get this whole thing out here to work on these. So what we're going to have to do is to remove this little daughter board here, which has the input from the mains and the wires that go to the transformer. These are connected by these little things that Sony likes to use. This is just a board that connects this to the front panel. And we're going to have to do quite some disassembly to get these off, I think. There is a plug that plugs in from the bottom on the front panel here and a plug that plugs in from the top. So this can just be lifted from this PCB here. So this is what we're looking at. We want to take this board out to be able to desolder the old flaky relays. There's a connector that plugs into this board from the top. And then there's this circuit board which just has some conductive traces on it to connect it to the front panel, which has a connector that plugs in from the bottom. I think you could probably flex this in a way to remove this, but I'm going to take the whole front panel off, I think, because I need to clean some of those switches anyway. We want to take this board out. We have to remove the back panel here, which is just screwed in, the speaker connectors, and we have to remove this here to get to that. So yeah, let's take the front panel off and see if we can get access to that. We are going to have to remove all these switches, which most of them should just pull out. Like these, and this probably. And you can also clean these very properly when you have them out of the system here, which is another nice touch. This has a little set screw, little hex screw, I think, that we want to remove. This is a 2.5mm hex bit that I have here. Yeah, you just have to loosen this a bit and you can pull this out. There's screws on the top here and on the sides that hold this in and on the bottom as well. So we have to remove all these. These are just Phillips screws. We also have to disconnect these, I think, in the longer run. But I think the front panel should come off if we just remove the screws now. And then we can work on these nuts here that we are going to have to remove to get to the circuit board and work on that. Of course, I disconnected the amplifier for this, so we don't run into any electrical shock issues. So now this whole thing should come off, I think. Which it does! Nice glue on there. Yeah, so in order to get access to the circuit board, we're going to have to remove this metal bezel as well. We have to remove all these nuts here to get that out. And we're going to clean all these parts separately, of course. That's going to be nice. And I think I'm just going to use a pair of pliers for removing the nuts, because this is all hidden anyway, so it's not like we're going to see the scratches we cause. Don't necessarily have to do this because most of the potentiometers can be reached with contact cleaner from here. But I think I want to at least take this channel switch completely apart. Maybe some of the other switches as well, because those were pretty flaky. It would be a good idea to take them apart fully, desolder them, take them apart, clean the contacts inside. And of course this takes a bit of patience, but it's going to be worth it, I suppose. So we should in theory be able to remove the screws here and here. And there's lots of connectors going to these. Yeah, there's screws in here as well. So here's a ground screw even. And there's more on the bottom. Yeah, again, there are 3 screws here. And then that should get the front panel off. This whole panel is now loose, and we just have connectors going to the board, which we can pull. So one is here for the mains switch that I already pulled, and there's another one here that should lift out. And I think we can get away with not disconnecting all of these. There's another one here on the side, which should just come out. Yep. So this connector, oh, this plugs into this, okay. But I think there might be a connector on the other side here to plug into these. Yeah, I think so. There are more screws here that we have to remove. Yeah, now the circuit board comes out. Oh, we can unplug this whole thing here, I think. Yep. So these things indeed plug into the circuit board from the other side. There's a connector on the other side that these pins plug into. And the same goes for this larger connector here that is here. Also for this smaller connector here. That is interesting. Interesting design here. So yeah, this is a part. You can see the connectors here that the pins plug into from the backside of the PCB actually. Pretty interesting. So the whole front panel is now separate. So now for the board we actually wanted to attack. We're going to pull this conductor board out, which is the same kind of connector. Yeah, that comes out now. And there's only traces on here going from one connector to the other. That is literally all this is. And now we have to remove this speaker panel here, which is connected to this circuit board, and unplug some plugs and remove some screws from the circuit board. And then we should be able to get this out. So we have to remove this, which goes to the transformer, I think, and this that goes to the mains. So there's 3 plugs, and these are actually soldered in. These are the speaker signals, I think, so the signals coming from the power amp. And then there's 3 screws that we have to remove to get this board out. It should be easy to do. And then this is also another 3 screws here. So yeah, this should now be completely loose. Oh, we have to remove the transformer, I think, as well, to get this out properly. That's a bit of a pain in the butt, but yeah. The actual repair is not that difficult, I think. But taking it apart and getting to the parts is the difficult part. There we go. Okay, that's our transformer out. Wow. And now we can pull this board through here. Do we? Yes. Okay, that should give us enough room. We don't have to remove these, I think, to be able to solder on this. So, and we should just pull the relays now with my desoldering gun. That should be a piece of cake, basically. This is a pretty nice design. They added some solder to some of the traces that have to conduct more amperage to widen the traces a bit. And I think while I'm here, I'm also going to resolder some of these connections. Just heat them up and resolder them. This is just a single-sided circuit board. This shouldn't be much of a challenge, really. So that should be the first one out. Yep. Can of course also use like solder wick or solder pump. But I have this neat little device which makes things a bit easier. Yeah, I'm also going to clean the circuit board a bit with some isopropanol. Yeah, let's replace those. I got some nice replacements. So yeah, these are the original ones we just desoldered. These are Omron G5R-2232P kW, and 24 volts DC is the switching voltage that is applied on these pins. And then there's an electromagnet here that closes the contacts between these pins here. So there's 2 switches in here basically for the stereo pair. So these are closed if 24 volts DC is applied to these pins here. That's how these work. There's a huge electromagnet that closes these contacts and then puts the signal out to the speakers. As replacements, these are no longer available. You can get them sometimes as desoldered components or stuff like that, but you don't need to source these exact models. You just want something that has the same footprint and the same switching voltage and is able to switch high amperage like these ones are. I don't even know. 5 amps, and I found these, which seem to be a good fit. These are Omron G2RG-2A4 24 volts DC, that's very important, switching voltage, and these are rated for 8 amps. So you want to have something that is rated for 5 amps or higher. So these are a bit higher rated, should work pretty much the same as the other ones. These are easily opened by pressing into these tabs. I've seen people doing that with two nail heads while these are in circuit, and you can then see the contacts that are just leaves that switch, and you can clean these contacts, which usually helps, but I just wanted to do this properly and replace them with new ones. These are readily available still from many sources. So these should fit in here. They are the exact same form factor. These were made in Japan. Now these are made in Indonesia, but that shouldn't be a huge difference quality-wise. So Omron has a good reputation. They make excellent stuff still. And yeah, we're just going to fit these and solder them in, I guess, after cleaning the circuit board some more. I'm just going to hold them in place while soldering, I think. I'm just tacking opposing pins to the board before I solder it properly, so I don't have to hold it in place the whole time. Yeah, so that should be our relays replaced with something new, and hopefully this is going to last for a while. And as I said, you can basically clean the old ones, but this is the more elegant solution. That's our new relays in. So let's put this circuit board back in, I guess. Oh, we should clean this before we do that. Underneath there's quite some dust, so we can use this opportunity to vacuum clean this a bit. So I'm just using a regular vacuum cleaner with one of these PC cleaning kits, which has a little brush and a hose which connects to the regular vacuum cleaner. Usually this works really well for things like that, to get into all the little cavities. Okay, now putting this board back in. And the transformer should go back in. Could add some more rubber underneath the transformer to eliminate vibration. Maybe that's a good idea. Let's see if I have some rubber washers. I'm just going to add these little washers that I have in my parts bin that I meant to be used for PC drives and things like that. Just doing that because the original rubber washers are pretty stiff at this point, so we have not much vibration isolation going on there. So I'm just going to add these on top there, tightening the screws quite a bit, so these are going to push into the original rubber washers and do some more vibration stuff. Not necessary really, but I'm going to do it anyway because I have the chance. And that should be relatively easy to do, I think, if we get everything positioned nicely. Yeah, that works really well. Can reconnect some of these connectors at this point. Ground wire is nicely connected. These are actually keyed. All the connectors that plug in are keyed to one specific direction, so no worries there. Okay, to the front panel, I think. So our front panel has potentiometers and these switches, and usually the potentiometers have a little cutout where you can spray contact cleaner in, and that's usually enough for those. I found you can desolder and disassemble them, but that's not really necessary in most cases. There are also these sliding switches, so you twist this and a little slider closes contacts on here. These are a pain in the butt sometimes because they get dirty or like slightly dislocated, but on this one these seem to be fine. The main thing I'm worried about is the input selector, which is this one. I think what I want to do is to desolder these 3 switches. So input selector, the other input selector, you can use this with a direct input kind of adapter thing. This is the output selector. We're not going to really need that to work properly, but it did. This is the selector for, what is it? This is the selector for the stereo and mono. I also want to give that a good cleaning. And the speaker selector is one of those sliding switches that I'm also going to just spray contact cleaner in from the side. We should be able to get in there quite well. Yeah, same goes for all the other switches, the push buttons. Just going to do some contact cleaner treatment. And I'm using a Tesla Knoll Oscillene for that. That's my favorite contact cleaner. Doesn't harm potentiometers. You want to make sure that you use something that's not corrosive to clean these. Usually what I do is to spray some in there, in the little hole that these have, and then just twist them a couple of times and spray them again to get all the dirt out. These ones I think I want to really take apart and clean the contacts internally. So that's going to be fun. I think that's the plan. This whole thing is still connected here because the power button is actually riveted in. So I didn't remove that, but all the other stuff should be pretty much very accessible at this point, I hope. Let's get these switches out here. Going to use my desoldering station again. Okay, desoldering these, and then hopefully we can take them apart and clean the contacts. We're going to see. Just going to start with this one over here and see if I can take that apart, I think. Okay, that came out pretty easily. Okay. So here's what these look like. This top part here is only for... It's not actual contacts. I think the contacts are in this blue part here that we should be able to get out here by bending these tabs and the center blue tabs. Yeah, I think that's the way. These are Alps switches, very high quality stuff. This is just some indentations to lock this in the correct position with a little roller here. Pretty interesting design, really. So we should be able to bend these metal tabs here and wiggle this out, and then the contacts should be in this blue part here. Yeah, it comes off. Okay. These can be bent together. And then the whole thing comes out. Nice. Okay, that's easy. And you can see the contacts in here are super dirty. So we're going to give these a good clean with some alcohol, Q-tip and some contact cleaner. And also the contacts on the other side, which are the ones that close the switches. And I'm going to do that for all the switches here. Some alcohol on there and a Q-tip. Oh yeah, okay. So no wonder this was flaky on the switches. So I'm going to clean this as well as I can and then put it back together and solder it back in. And I'm going to add some of my contact cleaner on top there, I think, to keep this from corroding. These can also get a little cleaning. Wow, these are also dirty as hell. And then this part lifts out. Oh, okay. I see. Really well constructed switches, but are dirty. If it's really super bad, you can also use like something abrasive. Might use a pencil eraser on these. That might be a good idea actually. Let's try that. Yeah, that works really well. And I think for the other ones I want to key this, so I'm putting a line on there to indicate which position the contacts are going to be meant to be reassembled. Of course we want to remove the residue thoroughly because you don't want any pencil eraser stuff in there. This is just going to require quite a bit of patience and some elbow grease. I'm going to do that for all of them, I suppose. And yeah, I'm going to finish off with a bit of contact cleaner that I just put on a Q-tip and then rub into these contacts, because that prevents further corrosion. Now we can bend these tabs outwards again. So it's going to be held in place nicely. There's probably a proper tool for that, but I don't have it. Let's see if we can get this reassembled in some proper way. It has it fits and it holds together, but it has a little bit too much wiggle room for my taste. I can't get these tabs to bend properly. This is not very ideal. So I'm just going to add a dab of super glue, some strategic spots. I don't think this is ever going to come apart again. So I'm just clamping this together with a bit of super glue in the hopes that this makes this stable. Could also add some baking soda to the equation, which should give this a bit of a kick. And then we should have a pretty stable connection there, hopefully. Okay, that did the trick. We have this now properly switching and it holds in place. Yeah, that's not the ideal way to do it. Just going to solder this back in. The direction this goes in is actually determined by a little cutout here and a little protrusion on the switch. Can't really go wrong there. We need to do the same thing for all the other switches. And as I said, I'm going to key these by just drawing a line on them, I think. This should be the point. So yeah, let's do these one by one. And I hope I'm a bit less destructive this time. Damn it. I broke this one too. We're going to see. Hate it. Okay, this one is dirty as well. Maybe we have to do some more gluing on this one as well. So maybe this is all going to end in disaster. I broke the whole thing off here at the end when I tried prying it out. The whole holder. Let's see. We're going to figure that out. So just a bit of contact cleaner on here. And a bit on the other part. And then this should go back together. Like so. Yeah, that one went together a bit better. That's actually not too bad. So this one went a bit better, but I'm still going to reinforce it a bit, I think, because it's still wiggling. Yeah, I'm just going to put a bit of super glue on there as well, I think. Just to reinforce it. Super glue and baking soda seems to do the trick quite nicely. You don't want to get anything in the contacts. You want the blue part to be movable because that's what's actually turning. But yeah, it's not easy to get these to grip. So yeah, I'm just going to reinforce this, I think. I don't know if anybody is ever going to go in this again. And on this side, as I said, I broke off the little tab that holds this. So a good idea to reinforce this a bit anyway. So yeah, baking soda, super glue. Again. Yeah, does it still twist? Yep, that's nice. So that can go back in the correct orientation, which we marked this time. So I'm learning all the time here. And hopefully this is going to work. So this goes in here like so. Wow, this is more complicated than I anticipated, really, cleaning these things. But it's going to be worth it if they work at all still, but they should. There's not much to it, really. Not much going on in there, as we've seen. Just the clamping mechanism is a bit shoddy. Or at least I didn't figure out how to properly reassemble that. Probably there's someone in the comments, so if you know or if you have a way of doing this, let me know. I think these are going to work without clamping them all the way down, but it's still better to make better contact, I guess. So, that's that one. And on to the last one, which is our main culprit. There's way more contacts on this, because it is the channel selector. And as you can see, yeah, no wonder this was behaving a bit flaky. There's lots of dirt on there. And I'm trying to bend these tabs again. Maybe it works this time. I still have some hope. It's not bad, but it still wiggles way too much. I mean, the contacts are spring-loaded, so probably this is going to be enough. But I still kind of want these to grab a bit better. Nothing much we can do about that other than gluing it down. Yeah, I don't really know how to tackle this any other way. So I'm just going to do my gluing trick again on this one as well. That should do. And back into the circuit board it goes, according to our markings. And I'm going to spray contact cleaner in all the potentiometers and things like that, and reassemble this and see if we actually made this work better than before, or if we completely messed it up, which is also quite the possibility here. Also going to spray contact cleaner in these little holes that contact from the other side. Okay, cleaning all the potentiometers and the other switches in here by just putting some contact cleaner into the little holes you see there, and then work these a bit. And basically the same goes for the sliding switches and the other switches. Just spray some contact cleaner in there, work it a bit, and that should be enough in this case, because these weren't too flaky really. The really flaky bits were these, the switches, channel switches and the other switches, so I hope we remedied that. I'm just going to use a lot of contact cleaner and then wipe off the excess. So I spent quite a lot of time thoroughly cleaning every little bit, and now we're going to let the contact cleaner evaporate a bit and then put it back together and hope for the best. It should be better than before, hopefully, at least. So this is the moment we've all been waiting for, or at least myself. I set all these up so that it's on CD input. I connected my phone to the CD input attenuator all the way down. Mode set to stereo. Record out selector off. Balance center, center, center. Speakers should be on A. So let's see what this gives me, if this still works at all or if it blows up. Just going to plug in now, turning it on. The relays should click, I hope, after a while. Yup, and we hear an audible click this time from the relays, which is nice. Okay, let's see if we can play some music on here. Also probably worth noting that these LEDs are just 2 red LEDs and 3 green LEDs. None of those dual color LEDs here. But yeah, the relays click, which is a very good sign. Music should actually be playing on the phone now. Let's see if we get anything from this amplifier. Yeah. Yes! No crackling whatsoever. No problem with the switches. Ah, excellent. I'm going to check the other inputs as well. But this is really promising. Ah. So our new relays work, our fiddly reworking of these switches also seems to work, for now at least. I think that was a success. I'm going to check all the other inputs off camera, just connecting the phone to other inputs and switching this around. And then we can probably reassemble this. I'm going to give the headphones jack a good cleaning with contact cleaner as well. So the way to do that is just to spray some contact cleaner in there, put a plug in and then wiggle it around. I'm also going to give all the little knobs and the faceplate a good scrubbing with some window cleaner and some alcohol. Actually using a Q-tip on the headphones jack here for a bit. Yeah, as I said, I'm going to clean everything that I have apart and then reassemble it fully and see if it continues working. So I'm going to listen to some music after reassembly and then report back. I'm also going to readjust the idling current, which we've done in the first part of the video, just to make sure that this is safe to connect to something. I'm just going to do the same procedure that I already did, so not much to show additionally. This should still be set up because we didn't change anything in the circuitry really, we just cleaned the contacts. Yeah, this seems to be fully operational again. I'm just going to have to do some more testing, letting this run for a couple of hours, listening to some music, but I don't see why this wouldn't work. All my switches seem to work. I checked several inputs. I readjusted the idling current, which was pretty much spot on still, as was to be expected because we didn't change anything in the amplifier circuitry. Once you change components in the amplifier, you want to readjust the idling current to that change because things change a bit and the bias of the transistors should be correct after that. So thank you for your time. Hope this was informative and entertaining. I think that's it for today. Thank you very much for watching. Special thanks to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page or elsewhere. The links are in the video description should you consider giving me some support, which is highly appreciated because it makes these videos possible. Hope to see you again on this channel sometime. I'm Jan Beta. Thanks for watching. See you next time. Bye!